gravitational effects of gravity on objects, weightlessness. At the end of the lesson, students should be able to explain the term gravitation and weightlessness, state the effect of gravitation on objects, demonstrate the effect of gravitational pull on objects. Gravitational force is an attractive force between any two objects with non-zero mass separated by a distance. Gravity attracts all objects towards one another. If the mass of objects attracted to one another increases, the force of gravity also increases. If the distance between the two objects that are attracting each other increases, the force of gravity decreases. Earth's gravitational pull is a force that pulls every object down to the center of the earth. The nearer an object to the center of the earth, the greater the gravitational pull. Acceleration due to gravity is the acceleration at which every object under the influence of gravitational pull falls to the center of the earth, and it has a value of 9.87 meters per second square. The gravitational pull of the earth is bigger than that of the moon because the mass of the earth is bigger than the moon. Mass is the measure of the amount of matter in a body, and it is denoted using small letter m or capital letter N. While the weight of an object is the measure of gravitational attraction on the object. It can be measured using a unit called Newton. And the mass of an object remains stable, both within planet Earth and on the moon. But the weight varies. The weight is not stable because the weight of an object is the function of the gravity working on the mass of that particular object, and weight fluctuates with altitude. The formula used to calculate the weight of an object is W equals to the product of mass times acceleration due to gravity. W represents the weight of the object, while the mass M represents the mass of the object, and G represents acceleration due to gravity, and it is always constant. Example: find the weight of an object whose mass is 4 kg. Take acceleration due to gravity to be constant, 10 meters per second square. Solution: the weight of that particular object is the product of the mass times the constant acceleration due to gravity. That will be what? 4 kg multiplied by 10 meters per second squared. That will give us a total of 40 Newton. So 40 Newton represents the weight of the particular object. Effects of gravitational pull. It allows a body to possess weight. The measurement of gravitational pull of the earth on an object is the weight of that object. The bigger the mass of an object, the bigger the weight of that particular object. Gravitational pull of the earth attracts the moon and keeps it revolving around the earth. It makes objects stable on Mother Earth. Humans walk freely on Mother Earth without floating or falling because the body of the human, that's the mass possessed by the human body, is attracted towards the earth. because the earth is bigger than the body of the human, and it exerts a greater attraction and pulls the body downward towards the body, the center of the earth's gravitational field. And that's why humans walk on Mother Earth without floating or falling. It keeps the solar system firm. The gravitational attraction of the sun keeps all the planets revolving around the sun, making sure that they are in place and they remain firm. Due to gravity, energy is required to lift an object up from the Earth's surface, demonstrating the effect of a gravitational pull on objects. Gravity is a force with which the Earth attracts objects towards its center, and it can easily be demonstrated. Example: if a ball is thrown up, the ball will go up and at a certain point stop before beginning to come down. This is because the force due to gravity pulls the ball to the center of the earth, and the earth is bigger than the ball, and it exerts a greater pull on the ball and attracts it towards the center of its gravitational field. Comparing two objects of same mass and different masses. Two objects of the same mass will fall at the same time. Also, two objects of different mass will fall at the same time, according to the law that governs gravity. Take for example, you have two hammers of 20 kg. You drop both hammers at the same time, both hammers will fall to the ground at the same time. Two objects of varying masses like a ball and a feather will not fall at the same time because of the air resistance that tends to affect the feather from falling downward. But if the air resistance is removed, both the ball and the feather will fall to the ground at the same time. See, the feather, the ball, both will fall down at the same time once there is no air resistance. This can be particularized using a vacuum chamber. This particular phenomenon has been proven to be 100% correct by astronauts that visited the moon. On the moon, they dropped both feather and 20 kg hammer at the same time because there is no atmosphere in the moon and there is no air resistance. Both the hammer and the feather drop at the same time. Weightlessness. It is a condition whereby an object traveling in outer space experiences the sensation of weightlessness, and that is zero gravity. The sensation of weightlessness or zero gravity happens when the effects of gravity are not felt. Technically speaking, gravity does exist everywhere in the universe because it is defined as a force that attracts two bodies to each other, according to a scientist called Galileo Galilei. And once gravity exists, take for example Mother Earth, any object, two objects of no mass or different mass will fall at the same rate because of the gravitational pull of the earth exerted on these objects. So they tend to drop, accelerate at the same rate because there is no air resistance. But if there is air resistance, if you are comparing with that of the feather, the air will push and break the fall of the feather. will not allow the feather to fall at the same rate. But if air resistance is removed, the feather and any other object will fall at the same rate. Because astronauts don't feel the effect of gravity, that's why they float in space. If you can recall, a space is just a point or a place beyond the Earth's atmosphere where there is little effect of the gravitational pull of the Earth. And that's why objects in space always float. Thank you for listening.